we're going to talk about probability distributions, right? That in statistics, basically, there is a topic of probability which says that any uncertain event can be made certain to a certain degree using probabilities, right? Saying that, okay, there is a 20% probability of raining today, or there is a 50% probability of this guy passing, or there's a 80% probability of this company going bankrupt. So basically, you add some quantitative certainty to uncertain events, right? And that's an important concept in statistics, the probability distributions. Probability distribution basically talks about plotting your probability of various events on that curve, very similar to the frequency distribution, if you try to remember, that we just spoke about some time back. That frequency distribution has frequency on the y-axis, and on the x-axis the number of times that the various events that could happen. So if I say that I'm doing a frequency distribution of various people falling under various age groups, then what would I have? On the y-axis, I have the number of people falling under a particular age group. On x-axis, I'll have that age group, that specific age group that I want to talk about, and then I'll plot that. That will be frequency distribution. The same way, if I replace frequency by probability in that same example, this becomes a probability distribution. You guys understand the idea of a distribution? Distribution is just basically data points plotted on a graph, more or less. Like, it's not exactly that, but I'm just trying to use that to explain it to you so that you guys have that intuitive sense of what it is. Remember that the whole objective of this session is intuitive stats, right? So the idea is not to give you the most advanced concepts. Idea is to develop intuition about statistics in your heads. So a distribution is basically what? You replace that probability, that frequency distribution with probability, and it becomes a probability distribution. In fact, you can also understand distribution just like that. You could show the same numbers in a table also, right? In a histogram, when they say that, okay, how many people are in age group of 0 to 10, 10 to 20, 20 to 30, all of you would have done this exercise in your school or high school or in your competitive exam preparation or CAT preparation. Somewhere or the other, you must have done this problem, right? How many people are in various age groups, right? 0 to 10, 10 to 20, 20 to 30. Have you done that histogram? So that thing is basically a distribution, right? Distribution is nothing but you telling how does the data look. So data looks like this, that so many people in this group, so many people in that group. That's it, right? So the same thing is with probability distribution that you're talking about. You're giving a sense of how the probability would look for an event, right? And even in probability distributions, you have the same thing, right? The way you have variables as discrete and not continuous, the same way you have probability distribution also in discrete and continuous format. Discrete probability distribution will be a binomial distribution in nature. When I say binomial distribution, I'm saying that there is a certain shape of that curve which represents binomial distribution, and it has some qualities, that some pre-existing characteristics that you could use when you analyze data or when you try to standardize data or draw some conclusions about data, and that can help you a lot when you do the exploratory data analysis, right? Or when you take call about how to exactly create model on a certain variable. And this discrete versus continuous, the difference is just this, that distribution for a discrete random variable will look like this, right? But the same thing for a continuous random variable would look more like this, the way we were looking at distributions, right? Distributions, there's a lot of fuss. I think a lot of people get really panicked about what distribution is in statistics, right? I guess you understood what it is. Binomial distribution is what? Let me give you a sense of that. A binomial distribution is basically, and again, I'm telling you, this distribution is basically a pre-existing shape of a curve in which you probably can say that this particular variable might fit. So binomial distribution, the easiest way to understand is that any event which has only two outcomes, any event that has only two outcomes. What does that mean? When an event only has two outcomes, then that event it's binary. When an event only has two possible outcomes, that event is binary. So in a binary outcome event, the probability of one particular outcome is basically represented by a binomial distribution. Examples are when a coin is tossed. So if you keep tossing the coin one after the other, your binomial distribution is the shape of the probability of heads or tails. And this formula, I know many of you may not be very comfortable with. That's why I don't want you guys to go too much into it. It's some combinatorics topic from your math. But what I would want you guys to understand is that this formula is basically talking about this, like it represents this. If you take this example, in a binomial experiment, the probability of exactly X successes, or you can say exactly X heads in N number of trials while tossing a coin, then this P represents here probability of success, probability of failure is Q, number of trials is N, and the number of heads is X. And the probability of X or probability of heads coming is NCX P raised to the power X, Q raised to the power N minus X. So this formula, this basically represents a binomial distribution. And how you can probably try to understand this is more from a intuitive sense, saying that if I do, like if I toss a coin 10 times, what is the probability of one head? Then what is the probability of two head? What is the probability of three head? What is the probability of four head? And you can assume that each one of these bar graphs that you see here, this discrete random variable one, each of the graph represents, like on the x-axis, each point represent one head, two head, three heads, four heads, five heads, six heads, seven heads, eight heads, nine heads, 10 heads. This will represent a binomial distribution. I am tossing a coin 10 times. I'm saying that this graph that you see here, this graph represents, each bar on this graph represents what is the probability of receiving one head out of 10, two heads out of 10, three heads out of 10, four heads out of 10, 5, 6, till 10 heads out of 10. Where will the maximum point be if y-axis represents the probability of those many heads coming for each point on the x-axis? So guys, if I have a fair coin, right? Every time I toss a coin, there is a 50% probability of me getting a head. So if I'm tossing the coin 10 times, there is a very high probability that 5 times I will get head and 5 times I'll get tails. That is what has the highest probability, right? So the center point, 5 heads will have the highest point on the y-axis because that will be the highest probability. Getting only one head out of 10 will be very low probability. 2 heads out of 10 will be slightly high probability. 3 heads out of 10 will be slightly high. 4 heads out of 10 will be slightly high. 5 heads out of 10 will be perfect 50% probability, which will be the highest point on that graph. And then again, it will start decreasing. 6, 7, 8, 9, 10 onwards again minimum. So that is what a binomial distribution basically is, guys.